Welcome to the Consulting Specifying Engineer webcast, How to Design Integrated Systems in Buildings, sponsored by Schneider Electric. I'm your moderator, Amara Razgis, and I'm happy to join you today on behalf of Consulting Specifying Engineer and CFE Media and Technology. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your own computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, please click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answer to Questions box. Please type questions for the presenters in the Ask a Question box on the left side of your screen. The live Q&A session will begin in about 45 minutes. Today's webcast is being recorded, and you'll receive an email within about a week to the link of the on-demand event. To download a certificate of completion and a PDF copy of the presentation, which includes several links, use the Event Resources tab on the left side of your screen. These documents will also be available with the on-demand version of this webcast. Okay, I'm happy to introduce today's presenters, Ram Kaushik, Jeremy McCullough, and David I. Ram Kaushik is the U.S. Offer Manager at Schneider Electric's Digital Power Division and manages strategic marketing for energy and power reliability within Schneider Electric's EcoStruxure Power Software Suite. Jeremy McCullough is Consultant Solutions Architect, and he manages business development, which helps customers design intelligent integrated buildings using Schneider Electric's latest BMS platform, EcoStruxure. And David I. is Consulting Solutions Architect, where he focuses on national-level general contractors and large, new, complex, integrated construction projects. He brings his skills, talents, and expertise to the Schneider Electric team. Thank you for joining us, gentlemen. The presentation is now all yours. David, let's get started.
Thank you, and thank you everyone for taking some time out to join this webinar today. I'm going to start off with explaining a little bit about our Proficient program. The Proficient program is very beneficial, especially across the engineering, consulting engineer spaces. We provide a large number of resources for you, including the expert access to help address questions and concerns around engineering, specification and drawings, online resources, and design support. After the presentation, you'll receive a PDF of this. So once you get that, you can open that up, and there's a link down here, which you'll be able to click on. That'll take you into the Proficient resources. These resources give you instant access to design documents. There's over 1,000 online courses you can take advantage of, as well as professional certifications in data centers and PEM. We have monthly webinars and on-demand webcasts that provide PDH certificates. And we also provide lunch and learns across North America from our team. Easy access to these CEU PDH certificates through the Proficient portal. Download and print those. And we collaborate with you across the solutions architects for design, application, and specification across integrated building systems. So we didn't want to kick this off without mentioning that. It is a very powerful resource, and we encourage you to take advantage of that. The objectives of today's webinar is going to help you gain a better understanding of the industry trends affecting digital application across cyber secure and mobile accessible solutions. And you're going to learn more about how the convergence of mechanical and electrical systems provide increased improved performance. We're going to review research and details around smart building technologies and how COVID-19 has changed engineers' focus in integrated systems. So we'll touch on some of that, how the things around the pandemic and what's going on in that. Learn how specific use cases across these technologies to improve safety, compliance, well-being, business continuity, and efficiency. First, let's take a closer look at Schneider Electric as a whole. We're very excited and proud company to help share with you the growing technologies across our company, providing energy solutions around automation, digital efficiency, and sustainability. And of course, our technology is very cyber secure. We've grown significantly across the globe with 135,000 employees and growing across 100 countries. Significant revenues of $32.2 billion, and 29% of that comes out of North America. You can see the distribution of that across Western Europe at 26%, 29% in Asia Pacific, 16% for the rest of the world. But we mention that because we also want you to understand we're on the forward, cutting edge and tested validation design architecture that we deliver. We invest 5% back into the revenues of the company for R&D. So we want to make sure that we're not just leading around revenue growth across the company, but we're leading from a technology sustainability effort. And that shows significantly. 44% of our revenues are coming from new economies. So you can be rest assured working with us, you're going to have the latest technology that has been tested and proven. Very significant. We're making a tremendous impact. Almost 50% of our customers' revenues come from digitization. And that happens through connected products, edge controls, analytics, software and services, and artificial intelligence and more. So we're going to touch on 3 key points that are being covered related to safety, compliancy, and health, resiliency, and business continuity, and efficiency. If you think about efficiency, there's a very strong need and drive around efficiency in construction in the building industry. User experience, occupant experience is at the forefront now. Before buildings are even, pen to paper is put down. I want to understand, what occupants are going to be in the building. How's it going to affect how my building's designed? Now, the buildings today have a tremendous stakeholder around value. The value of that building, not only early on as the building's opening up, but for many years to come. What's going to affect occupants' comfort, efficiency, safety, optimization. These 3 trends are very powerful mechanisms, and we have to address them. So we're going to share with you what that looks like. Let's take the first one, safety, reliability, and wellness challenges. If you look at the annual cost damages due to cybercrime out there, it's over $6 trillion. And that's growing. Over into 2021, they predict it'll be even higher. So our technologies have a tremendous investment in cybersecurity end to end. That effectively increases the occupant safety by having that move from our digital products all the way through our applications. 30 to 40% of HVAC and downtime is related to power issues. So that's another key component of reliability and resilience, understanding what that means and how to have the intelligent power systems in there to maintain that resiliency. And we know that 82% of millennials are, they're looking for technology that's going to influence where they work and what buildings they're in and what environments they're in. And 10%, we're seeing a 10% decrease in employment performance across workplaces that don't have very good air quality. Poor air quality, it's too warm, or it's too cold, humidity doesn't feel right. So, the comfort level, safety, reliability, and wellness are very important as they kind of, combine together. The second pillar we want to take a look at, and the second key point, is related to the business continuity challenges. Across business continuity, $150 billion in outages are seen every year. The continuity has to be there. It's typically missing or it's not aligned the way it should. 50% of the equipment downtime, I mentioned, how power issues can be affecting the whole environment. And 40% of the service workforce, we know that they will retire, by the end of this year. Those numbers are expected to go up rapidly. So I mentioned the millennials coming into the newer buildings now. They're demanding high efficiency applications that run at their fingertips that can affect the comfort in their environment. 88% of organizations have encouraged required employees to work from home. You think about the pandemic recently, and I'll touch on that again a little bit later, but that's even heavily affected above and beyond the normal rate for people working from home. And finally, thirdly, the key point around efficiency itself. How much energy is wasted typically from an HVAC system? 25 to 45% when it's not set up properly, it's not measured properly. So we know that there's a huge impact and we can affect change there. Unscheduled maintenance in instances due to the data that's available, but maybe it's not being properly managed or tracked to affect change in the maintenance schedule. Over 39% of global energy, CO2 is attributed to buildings, and 30 to 40% in the workplace is just underutilized. So you think about, the smart buildings, smart space, consider that 75% of the building's main life cycle cost happens after, turnkey, after the building's up and running. Early on for a new construction, for example, 25% of investments going into that phase. And once the keys are turned over, again, 75% of that cost is for the life cycle. Is it a proactive look at the building maintenance, and are there analytics and deep insights being leveraged? We can significantly increase the building's overall efficiency with our solutions in place. I did mention COVID-19, the pandemic, and some of the pieces of information in there that I mentioned early on, but I wanted to touch base on this. The CFE Media that we worked with did a survey recently with Schneider Electric. On this survey that focused around the future and the near future impact of this pandemic across non-residential engineering markets. 79% said that they had an increased demand for smart building technologies. You think of how much you use your mobility applications, and Jeremy and Ron are going to talk about this in the presentation, but more and more of us are using smart applications to affect our environment where we go and how that's controlled and the ability to do that. The anticipated project requests across buildings to reopen, take a look at that. HVAC, 66%, automation and controls, 59%. But look at smart buildings technology. It's rapidly catching up here, 57%. So we're going to see a lot more of that as we move into 2021 and beyond. So I wanted to give you some keys to designing the future building environment. And take a look at these keys from an innovation perspective: reduce risk and increase productivity. The applications wrapped around the future IoT platform, they're very unique for building management and power distribution. Schneider Electric has a streamlined model. We have a very clean platform end-to-end across different business units. We're looking at the building across the entire spectrum, from power to energy to IoT and so forth. And we're leveraging that against what's going on with risk. Reference the design recommendations to comply with codes. So not only looking at the innovation, but understanding the risk involved and driving risk down. We want to make sure you understand, lean on the network of experts when you need them. Our team, our resources, our eco structure solutions, and how we leverage those for you. This drives productivity also. Increase the productivity. Our solutions are proven, they're tested, they're validated designs, and guides and design software tools are provided to make it much easier. So additionally, there's a gateway to integrated building design. And Schneider Electric's EcoStruxure is the main platform to do that. It's leveraging buildings and power. It's leveraging the integration between different systems. There's multiple systems that come into play, reducing the risk ensuring occupant comfort, improving building security. I mentioned the security, there's not just hard security, CCTV access controls, but cybersecurity end to end. Improving the sustainability and compliancy. Very, very, very important. And resiliency, we hear on a lot of calls, a lot of meetings we have now, resiliency. We're hearing that a lot more than ever before, especially across healthcare, or across federal DoD markets, financial markets, and others. The minimize building disruption and downtime. The resiliency is a very key point. It's got to be efficient. The efficiency to reduce the energy usage and optimize your building environment. And again, I mentioned cybersecurity. But of course, it's all a connected environment. We really believe it's possible to, make buildings truly sustainable and efficient and fully connected. It's really as connected as the owner or the engineering team wants it to be. And looking at that in another way, you can think about the kind of a circle or a cycle that connects everything together. The open integration platform that drives these multiple systems to interconnect together goes across commercial buildings, healthcare, data centers, industry, and infrastructure. It's a full life cycle of design, from specifiers to contractors, panel builders, systems integrators, operations, and maintenance. And over on the right, we have the eco expert group, covering the critical power, substation automation, digital panels, power services. You can see the list there, driving these solutions together. It's really turning the entire systems together, the data into actionable intelligence and optimization to perform and create productive environments. So there's more that goes into the building, than just taking a look at one of these all by themselves. We're really looking at the building as a holistic approach across, what affects the building for the users, the user experience, the sustainability, efficiency, the cybersecurity, and driving those technical solutions together to produce business outcomes where actionable resources can take place. And the data that's in these buildings that's being leveraged to take true action on how the functionality affects occupant outcomes. So let's talk about some of those solutions. So driving those solutions forward, I'm going to hand off to Ram here to start this off, but a digital application summary you see talks about safety, compliance, and well-being, business continuity and efficiency, as I mentioned. But we're going to drive into some of those solutions and how they work across each of these areas. So Ram, if you will take the helm here, and then Jeremy, we appreciate your participation together.
Thank you, David. Appreciate it. As you can see, David organized the use cases listed here in these three value buckets. So that's really how we have combined the approach for buildings to integrate facility management and power together. So you'll see these use cases kind of span the gamut from traditional BMS domains to maybe traditional power management domains, but they sort of bridge that the combined world. What we found is, most campuses or building complexes really, they have a lot of asset value in the power infrastructure as well. So I think the last estimate I saw was 20 to 40% in some cases of your asset value is actually tied in your power infrastructure in some cases. So those use cases which are power centric are worth assessing carefully as well. So we will look at a few of these use cases in more detail. Obviously, in the interest of time, we won't hit them all, but let's take a look at a few choice ones. So the first area I want to cover is the area of reduced risk, and we'll pick one of the use cases. that is in our application stack. And this is related to thermal monitoring technologies, which sort of continuously look at temperature measurements inside critical power infrastructure. So if you look at the way this is done today, traditionally, it relies on this idea of third-party infrared scans. So you have companies that actually look at, they would come out and do a full scan of your equipment using infrared technologies and then assess the risk of maybe overloading, creating a fire, things like that. What we have found is this periodic test, firstly, they're expensive, and secondly, they're not it's a reactive mechanism. It's not really a proactive, predictive way. And there's actually measurements inside these critical pieces of equipment where if we measure at bus bars in certain critical locations, we can actually make a pretty good guess as to the health of that equipment. So these technologies involve sensors inside these pieces of equipment. You can alert based on temperature changes from a baseline. You can also go the extra step if you want a service bureau, which is remote, to actually look at the data and identify an anomaly way ahead of time, right? So you can set some basic alarms at the facility software level, and then if you can bump up to this proactive service if you need to. Okay, so that's sort of clearly this sort of continuous thermal monitoring technologies are easier to apply in a greenfield project where you have control of the specification before it goes in, right? In a brownfield application, sure, we can retrofit sensors and get these technologies moving, but it will be a little more onerous. It's going to maybe require some outages to actually go in and make sure the sensors are installed correctly, but it can be done. Okay, so that's sort of the first use case I wanted to put in front of you guys to on your radar when you examine what technologies you want to include in a smart building specification. Okay, so let's look at another area of value, which is how to minimize disruption and downtime in a building campus. So from a power perspective, I would venture to say that many critical monitoring points are basically, a lot of operators are actually blind to those points today. There's a lot of unmonitored infrastructure. So key circuit breakers, for example, transformers, pieces of equipment which really sort of are the critical lifeblood of your campus are often unmonitored, right? So this is like not monitoring your, the cholesterol level of a heart patient, right? It's not exactly a good practice. So what can we do? Well, we can bring in power monitoring points, critical points like, condition alarming, maybe measurement of peak demand, loading, things like that. You can bring the data from the IoTs so that it's visible from your management system, whether you have a dedicated power management system or whether you want to take that data and integrate it with the building system. That's an implementation detail. But the ability to bring that data and do something with it. So things like real-time monitoring of the system with animated one-lines, maybe some smart clustering and grouping of alarms so that you don't have this alarm flood when something happens. Right? So there's some sort of operator ease of use things in this use case, but that's the main point is to integrate critical monitoring points with your other building facility systems. Okay, let's move on to the next use case. So if you look at many building campuses today, They all have significant emergency power infrastructure in terms of generators, UPSs, etc. Monitoring and testing of that emergency infrastructure is very spotty, right? It really depends. Some organizations do it very well, maintain good documentation, others don't. Monitoring these pieces, critical pieces of gear are really important. Periodic testing is important as well. In some domains like healthcare, regulatory bodies actually require you to maintain this kind of documentation, right? In healthcare, for example, there's a requirement for periodic generator testing and maintenance of that documentation. So there's key benefits here in terms of automating this kind of test results and actually storing those results. So if you get audited, you have that, right? A facility has that. And I would also venture to say, even if it's not a requirement from a regulatory standpoint, it is still good practice, right? Critical power is a key facet of your campus in some cases, and in mission critical facilities, absolutely, right? So I would say, some kind of backup power testing, sort of asset management use cases these are very, very important for campuses, and it's important to spec these early as well. All right, let's pick up one more of these use cases. Let's look at power events, and what I mean by a power event is it's not your HVAC schedule being late by 5 seconds, right, or 5 minutes or an hour. Milliseconds matter in power equipment. When you have transfer switches operated, or you have generators turning on to maintain critical life safety equipment, milliseconds matter. And if something goes wrong, tracking those events in a sequential, orderly manner is hugely important. So sequence of events reporting with some good analysis tools really help you prevent future outages, right? So for example, arranging the events in a timeline so an operator can quickly assess what happened, right? Did the transfer switch and the load management system operate the way it should have? Maybe you had a stuck breaker, or you had a wrong priority on a load restoration scheme. You will not find that, right, as an operator, unless you have good analysis tools to do this. So power event analysis is another use case that I want to at least bring into your radar when you plan for these systems. All right, so let's move on to something maybe a little more mundane. Moving from critical power applications to sort of just energy cost and efficiency. As David pointed out, efficiency is a big deal. So let's figure out what we can do from an energy efficiency standpoint. So in some facilities I've seen this, the single largest operating expense they pay is a utility bill. And I have found that in many cases, a lot of organizations simply do not verify this, right? It's assumed that the utility got it right, which is true in most cases, but certainly not. Errors are actually surprisingly common, and when they do happen, they are pretty high volume in terms of dollars. So verification is a good thing. And how do you verify this? Through a process called shadow billing, which is you try to mimic the utility bill from within the organization, knowing all the billing determinants. So it's not just energy use. It could be a number of other components which you need to kind of mimic with your data and try to reproduce the bill and find discrepancies. So I would also venture to say that there is a side benefit in understanding these billing levers and try to reproduce the bill in all those levers. And the side benefit is it generates ideas on how to change the dynamics of energy, right? And it gives you good data to go back to utilities and negotiate rates, right? So it's not just a sort of, you run this verification exercise for 3 months and then say, okay, utilities seems to be getting it right consistently, therefore I'm going to stop doing this, right? That's not the point. The point is to actually examine these energy efficiency levers and keep continuously monitoring it to see how you can do better, right? So that's part of this energy efficiency exercise. And so that's a use case that we do quite frequently in Schneider. We combine building and power and actually report these kinds of billing errors. Okay, so the next case I want to look at is energy modeling. So this may not be everybody's cup of tea, but for large energy users, building an accurate energy model has some significant benefits. One is predictability, right? So if you've built a good energy model, you have quite an accurate assessment of what your usage is going to be given the what I would call the independent variables, weather, occupancy, maybe a few other in a production context. It could be if you're manufacturing something that would play into your energy use and your model. Okay, so once you identify the variables that go into a model, building a good energy model really has some tangible benefits. Predictability is one. It enables you to negotiate with utilities based on solid data. If you can tell them exactly this is going to be within 10% error, this is what I'm going to be using for the next 12 months, and here's the profile. That's worth something. Tracking the return on investment accurately after, say, an energy efficiency project. If you put in new chillers and you want to assess the return on investment, what you can do is track the drift from the model and then quantify that drift, right? The variance from the model after you put in an energy efficiency program is really hard dollars that you've saved. And that's something that a facility manager can go back to management and say, this is the return on investment, and I can prove it. So that's also a very tangible value. But like I said, energy modeling is sort of an iterative service. You have to sort of refine the model. So it's really not everybody's cup of tea. And we are actually delving into sort of providing this as a service, right? We have a few customers where we would look at the data for them and develop the model and track it and things like that. But regardless of where you do this, go to an energy service company or spec it in as a ongoing service. I just wanted to put this use case in front of you as something that's of tangible value in smart buildings. Okay, so that's sort of a few of the use cases that dealt with safety and energy efficiency and some of the the power, critical power aspects. After that, what I'm going to do is turn it over to Jeremy, who's going to cover some of the occupant comforts and some of the other business continuity use cases. Take it away, Jeremy.
Thanks, Ram. Good afternoon, everyone. So as Ram mentioned, yes, I'm going to hit some use cases between each of the verticals that you see here. One thing I really want to point out is, and if you haven't noticed it already, but many of these use cases that you're seeing, and it goes back to really the title of this presentation, is that we are building these use cases with integration between variant systems, most importantly, usually the HVAC BMS side and the power side. And a lot of this has to do with all the benefits that we're talking about, but it also leads us into how we have to go about a change in how we are designing buildings today. And it's telling us that we cannot build in these silos anymore. We cannot just think about what the BMS platform and an HVAC will be doing. We have to take into account what we can do when we pull in power, or if we pull in security, or if we pull in any number of third-party systems, say nurse call or infant monitoring in a hospital. What are the benefits that we can have of it? What are the infrastructure savings that we can have out of it? And so just keep that in mind, and I'll give you some references near the end that'll help you down this path. That'll get you to an ease ability when helping design buildings that have these integrated platforms. So I'll hit on a couple of these on each of the verticals, and then I'm actually going to end on the two you see at the bottom, which cross all platforms, which is the cybersecurity as well as the user and mobile experience. So we'll start with the ensure occupant comfort section. And what we're seeing in the market is we used to, have all these disparate systems where in, say, a conference room or an office, et cetera, or even a hotel, that we would have a system working on, just HVAC. And then we'd have another system that would handle our lighting. And then we'd have another system that would do blind control. And then we'd have another system that would maybe handle AV within that room. And what we're seeing now is a convergence of all these systems, not just because there are savings in building such convergencies, but the benefits that we get when we start combining these things, particularly when you start talking about HVAC, lighting, and blind control. All of these really need to start working in conjunction. There is no reason why the light should be on if the room is not occupied, and the room should be set in setback on the HVAC side if it's not occupied. And if it's unoccupied during the day, why don't, and let's say it's hot outside, and we're not exactly to set point, well, let's raise the blinds and push the setback in the room back and let the sun heat the room instead of us. There are tons of efficiencies in it, but on top of that, connecting these is allowing us and the users to interact with the environment in ways that we haven't had before, particularly when you start thinking about the pandemic and the COVID situations we've been around. We have had countless conversations over the last 6 to 9 months about how we can increase the user interaction environment, but also make it touchless. Well, how do you do that? Well, in the past, you would always go to a wall to change the temperature, and then there would be another sensor that you would have to mess with for the AV, and then you have another sensor that you have to go mess with for the blind control. And you have another sensor that you go turn it off or a switch to mess with the lighting in the room. And we've got buildings today, that's not necessarily the case anymore, where each individual user can use an app on a tablet or a cell phone, et cetera, to not only manipulate lumens and temp and AV equipment and blinds, et cetera, in the environment, but do other things within it. It's a one-stop shop and allows them to use their own device, thus keeping touch services down to a minimum. And as David had mentioned before, the increase of millennials in the workforce and the increase of our connectivity in our home environments are dictating this in our spaces that we work in and live in for most of the time. Think about your homes and all the connectivity that you have. I just got done this weekend installing, I think it was a total of 12 smart plugs in my house to operate all the Halloween decorations. Yes, I know it's September, in my house. And what's great about it is I can turn on and off individually via an app if I wanted to, or I can actually just tell Alexa to turn on the lights. And in fact, I just did that. Unfortunately, all my lights are on. And I do that in one fell swoop, and I can do that when I'm going to sleep as well. And if there's one that I want to turn off, I can do that immediately from voice command or on an app as well. I love this convenience. And what we find is when we leave these connected environments that we tend to not have these, and we don't want to be in those environments. I typically always ask this question when I give conversations around connectivity and the benefits that you get, but many of you have probably taken an Uber or Lyft, right? And how many would you leave that experience and go back to taking a taxi? Not many would, because of the benefits that you get out of contactless payment. They know where you are, you can track everything, they know where you're going. You can track the route so you know that they're not taking the long way around, upfront costing, et cetera, et cetera, et cetera. And that's what we're seeing, a big push in demand in the living spaces and in the commercial office and other commercial buildings. So within that realm, we have this workplace and occupant experience that we really, really want to push. And what we're finding is that not only giving them access to this environment and control their environment, but we need to see how that environment's being used. Not only how, the temp and humidity and CO2 is in a variable space, but with the advent of a dearth of office space today, because many are working from home, how do we utilize the space to its best benefit? And the only way to do that is to baseline how the building is being used. What cubicles are being used? How often is this conference room being used? And not only are you looking at that environment and how those are being used so you can allocate space efficiently, but you're also using that information to dictate how other things work in your environment. For instance, if a conference room is not being used at all that day, then we could send a signal over to cleaning services and tell them not even to go into that room, right? They can spend their time doing something else. We can use these sensors that are in the environment to even expound upon what we can do, from wayfinding to geolocation, even if you want to. Where's the closest coffee maker? Where's the closest bathroom? I need a conference room closest to me that's unoccupied. We can do all this via an application and be able to see that and instantly book it if we want to. And a lot of this is built around, again, the occupant experience. But when you start looking at facilities and how to efficiently maintain them, then you start looking at the analytics that we can apply over a building envelope. So in the world of occupant experience, it might not necessarily be an energy expenditure or a maintenance issue, but analytics will also point out comfort issues. And in fact, when we deployed analytics many years ago into many of our buildings, we initially thought that the energy expenditure would probably be the biggest thing that facility managers would look at. And what we found out is that they actually would look at the comfort level more than anything else, because that's where they spent the dearth of their time, is doing hot and cold calls. And what they found out is that they attained to those and went after those to satiate those in the space, they actually ended up getting to the faults and the issues in the building at the same time. Yet, in addition to that, they kept those people happy. So it was a win-win on both sides. And so analytics is probably one of the most efficient things you can put into a building today. And a lot of that leads itself to the amount of information we're getting. There's so much data coming in that we just can't sit and look through this all. We need some help. We need cloud-based computing and AI, et cetera, to assist us in how we maintain those facilities. So let's look at security. So since we started doing BMS and security in the space in the DDC world, there have been plenty of specifications where we asked to integrate the two. In this case, what we're looking at is integrating more outside of just bringing in security into BMS, but what can we do when we join these two systems together? And a lot of this is around not just security, but situational awareness while you're in these environments. And you'll see this inherently built into some hardware, for instance, card readers and access panels, where color codes or blinking of lights can dictate what type of event is occurring, whether the door is locked or unlocked, or if there's someone who has been unauthorized access into this, or if there is say, for instance, a shooter on site, unfortunately. These things can alert those in the space. But if we start pulling in other systems, say lighting, then we can actually alert them in other ways. What if we use the LED lights to dictate or send messages to those in the space? What if we illuminate certain spaces that we know have just been intruded upon to push people away from that space or have them leave the scene? What if we lit space up to those that are in the building that we're aware of and show them where to go to leave an area that might be of an issue? These are all things that we can do where we pull in that security knowledge and integrate that with that lighting system in order to dictate those runs for them. Let's move into asset management. So what we're looking at is back to what I was saying before about fault detection. So what we do within Schneider, and this is not just within BMS, but we also do it within Power, and it's not just within our systems, but it's agnostic across the board. We can pull any open system and even some proprietary systems into an analytical platform and actually push out fault detection and ways to fix these issues in your building. And many that have gone down the analytical path have used this to transform their maintenance within their building and use that as not a let's go and change the belt on AA212 because it's been 12 months, but to look at where our biggest cost and energy efficiency issues are and go attack those first and attend to the other ones later. And the amount of savings you can have just on the analytics itself is huge. So I highly, highly suggest you take a look at those platforms. And let's move into our last one here before we get into cyber and user experience, but the optimized building environment. And I picked this one personally because this has been a big conversation, outside air demand ventilation, which we've done for quite some time. ASHRAE's got a minimum standard, let's just say it is minimum. And it's made that way so that we are not only addressing air for those in the building, but also keeping energy use down. But now with the pandemic and COVID, we've got a lot of people coming in and wanting to filtrate that air and more outside air ventilation so they can recirculate that air. But if we do that, of course, our energy costs go up. So looking at metering and control of these devices at the same time can give us a happy medium where we can recirculate that air, but do it at the most cost-effective way possible. And we've taken these measures already, and we've been provided dashboards and things in lobbies where people can walk into a building and see how quickly this space has been ventilated so that they're a little bit more at ease coming into, say, a commercial office space. We find that a lot of these tactics are allowing people to be a bit more comfortable coming back to work as we move into the new norm. So let's briefly talk about cybersecurity. It touches everything. I'll make it very short and sweet. Everything you see on the right-hand side is best in class currently today. It's what we deploy within our specifications within Schneider. It's what we deploy in our software and hardware platforms. We have a full cyber certified team as well as a full life cycle deployment. It's one of the first things we attacked when we went down the EcoStruxure path 10 plus years ago when we started building the platform. And all of these items that we're bringing in together are on an IP network for the most part. And we have to be able to secure those items and create an environment where even though we're bringing in more connection, that when we do that, we're keeping that secure for those environments. And we could spend an hour talking about how people have gone into BMS systems and tried to get in. They didn't care about the BMS. They cared about getting onto the IT network and finding ways to get into their systems. We have to be proactive and keep those systems secure. And then last but not least, on the user experience, which has been a big conversation of lately and even before COVID. Within Schneider, we have something called an Engage app. And essentially what it is, it allows you to pick and choose what you want as a client to control or have users have access to. And we have so many interactions with third-party systems, and this, what you see on the screen is a small list of it, of things that you can actually interact into an app and give them access to. The basic ones that we typically get into are comfort control, using your phone as an access badge, allowing them to navigate the indoor space, but then pulling in company stuff like booking a conference room or looking up a company profile and finding, where they may be in a building, or just filing a maintenance ticket because you've got an issue in a space that you're in. And it's really dependent on the user and whoever's designing the building, what you want to give them access to. But the key point is we can pull all these together and give that to the end user. And it starts with combining these disparate systems because you can't give them this type of experience without building the building in that way. So to bring this full circle, back to our original slide, we didn't touch on every one of these, but we could and be more than happy to discuss these at a later time if you wanted to reach out to us. I will mention here in a moment, and I'll go ahead and bring it up now, is that we do have what we call a Division 25 specification. If you're not familiar with it, we'll be happy to expound upon that as well. But that is a portion of specification that is built around really bringing these integrated systems together and bringing use cases on how we integrate those two and what we actually do with them when we integrate them. We've seen so many integrations done in the past where we just say, bring in this into the BMS or et cetera, and then they're done. But what benefit does that give you or the end user? We have to be able to say and actually validate and prove and perform bringing these systems in and actually providing a value when they're integrated. So I highly suggest you go out to learn more. Check us out at se.com. And then I also mentioned the Div 25. We have an access portal. You'll have a link to it later where you can actually go out and pull our current Div 25 specification. It does have a lot of use cases in it. We are adding more use cases all the time. We would be happy to hear from you on which ones you think are key for your customers or for yourselves, and to provide those as well. But in the one that you'll download, we provide about the top 10 most used use cases that we see in the market today, the ones that you'll probably ask the most questions on. So I highly suggest you go out and check it out, and please give us feedback. I appreciate it.
All right, excellent. Well, thank you, gentlemen. Now these expert presenters will answer questions from the audience. Please type your question for the presenters in the Ask a Question box on your screen, and we'll get to as many as time allows. Questions that we do not get to today will be posted online at www.csemag.com with the archived version of this webcast. And please remember to download a certificate of completion or a copy of this presentation. Please use the Event Resources tab on the left side of your screen. All right, let's see. Jeremy, you ended the presentation, but you're going to start the Q&A for us today. Let's take this very first one, and this touches on what you kind of finished off your presentation with. Which facility control systems are typically integrated into the Division 25 front end? Which ones are, which ones aren't, and why aren't they?
It's a good question, and well, to be honest with you, it's a pretty wide open one, because pretty much almost anything really could be pulled into a Div 25. When you get, the only roadblocks you run into is how can they? Not everything works in an open BMS protocol world, meaning BACnet, Modbus, LAN, et cetera. But that's where some of the new technologies and IoT integrations have come into play. We do integrations through MQTT as well. When you're looking at third-party systems that are proprietary or use a different language, in the world of Schneider, we've got over 400 open APIs, which we call smart connectors, that actually can bring these systems into that single environment. About the only one I ever see that we don't fully integrate into is Fire. You'll see integrate Fire a lot into BMSs. That's not a true integration. When I say integration, there is read-write and conversation between the two systems. But Fire itself is usually one way. We're monitoring. We're not sending anything over to the Fire system. But that's probably the one that, out of hundreds upon thousands that you can probably sit there and talk about, that we do or do not pull in. So the world is really your oyster, depending on what you want to do.
All right, thanks, Jeremy. Good way to explain it. David, this next question is for you. Could you please expound on the need for double and triple redundancy for all the applications? What are they?
Absolutely. So there are a number of applications, and this goes across the hardware and software infrastructure through our EcoStruxure platform. So when we look at redundancy, there are architecture redundancies that we have inherently that come out of the box with our designs. On top of that, for higher level redundancies, we have customers in the Fed and DoD space that require, very high levels of redundancy across BMS systems, IT systems, networks, power. We think of additionally to our, power and BMS systems, grid, microgrid. So, as Jeremy mentioned, the world is your oyster. It really depends on the level of redundancy they require in their project. and we typically will have that available either out of the box or just doing some additional add-ins on the redundant plan that they have in place. Additionally to the hardware and software, we've got a lot of cloud offers that can tie into our technology as well as other agnostic vendors' technologies to increase redundancy.
Got it. Thank you. Jeremy, another question for you. Is Schneider Electric providing non-proprietary protocols or connection options to other networks? Could you explain that a little bit?
Sure, and this kind of leads back to the first question where I mentioned building open protocols. So we are an open platform, meaning our system provides all the standard open protocols in the market today. Again, that's BACnet, Modbus, LAN, Zigbee, etc. When you get into areas where these systems don't use those particular protocols, I wouldn't say we're providing a non-protocol connection to them. What we're using are either web services or open SDKs and APIs to connect these. A good example would be, say, a hotel. Their guest room management platform is not a BMS platform. They do not talk with open protocols. In order to bring that into the infrastructure, we use something called a smart connector to connect that guest room management solution into the guest room controls to integrate those two and have those two talk with each other. And again, as I mentioned previously, we have over 400 of these for all variant systems out there, and we're adding new ones every day for new products that come out that want to be integrated into a singular environment.
Sure. Good to know. We have, it looks like time for one last question, Jeremy. Let's see if this is the last question. Is commissioning a key to getting working systems to hand over to operations at the end of a project?
Well, yeah, straight-laced, yeah, absolutely. Commissioning is key. Commissioning was always brought in to be a third-party overlay because controls, for those that aren't familiar with them, it's like speaking another language. And we need assurances that this is done correctly, right? Well, part of that also lends itself to the fact that integrations of variant systems, different disparate systems, can be more complicated. And how do we ensure that those are done correctly? And that kind of leads us back to the Div 25 conversation, where the Division 25 specification is very particular about how these integrations are going to occur. It's just not a single line that says bringing this into the system. It says when we do it, how we do it, what protocols are we using, what hardware are we using, what's the end use case, what's the end result that you get, so that we are more proactive at the beginning to set this up correctly so that when commissioning does show up to actually look to see if we've done it correctly, they're not running into a lot of roadblocks and issues that they found where this didn't work. We're trying to back this up at the beginning and ensure that things are documented and tested and already validated and done before we ever even get down to the commissioning set point.
Okay, Jeremy, so I have a quick add-on question that goes along with that. Sure. How do you find integrators that can do the work? How can you bring this all together with an integrator?
Excellent question. So I would reference back to what David showed. I think it was slide 2 or 3 to the Proficient portal, particularly if you're an MEP. This site will give you access to integrators in your area that will be able to do all the things that we've been talking about. If you're not a consultant, because Proficient is very much a consultant web portal, se.com will have that particular information for you as well. And of course, you can feel free to reach out to people like myself or David I, or even Ram. That's our day-to-day business, is connecting people to solutions, to people that can execute those solutions, and we'd be happy to help you.
Very good. Well, thank you to our excellent speakers, Ram Kaushik, Jeremy McCullough, and David I, for sharing their time and expertise. And thanks to the audience for some great questions. I'd also like to extend a special thank you to the sponsor for supporting today's event. We are just about done, and we want to hear how we did. An exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, I'd like to thank you for attending. This now concludes our webcast. Thank you and goodbye.